Formula writing in organic compounds. There are three types of formulas that you will see in organic compounds. The first one is structural formula. The second one is condensed formula. And the third one is called bond line formula. The bond line formula is written based on the shapes of the individual carbon atoms that are present in the longest carbon chain. And in order to understand that, we need to know the hybridization of the different carbon atoms in alkanes, alkenes, and alkynes. We will just take a look at the different shapes of carbon atoms when it is an alkane, alkene, and alkyne. If the carbon atom is an alkane, where each of the carbon atoms are attached to 4 other bonds or forms 4 single bonds, then the carbon atom would be tetrahedral in shape with a bond angle of 109.5 degrees. If the carbon atom is attached to a double bond, then it undergoes sp2 hybridization. The shape of the carbon atom would be trigonal planar, and the bond angle would be 120 degrees. If the carbon atom is attached to a triple bond or an alkyne, then it undergoes sp hybridization. The shape is said to be linear, and the bond angle is 180 degrees. Let's look at an illustration or an example. This is the expanded structural formula of an organic hydrocarbon, which is an alkene since it contains a double bond. We can condense the hydrogens and represent it like this. This is easier to understand how the carbon skeleton is arranged, so it's a very good way of representing it. Right now I've taken away the hydrogens and only put the bonds there. You would notice that carbon is tetravalent, therefore every carbon atom has a valency of 4. If it's an alkane, it'll have 4 single bonds, and if it's an alkene, there will be 4 bonds, of which one of them will be a double bond. Now, taking away the bonds, we can actually assign shapes to these carbon atoms depending upon whether it is an alkane or an alkene. So let's associate it with hybridization. Now, if you look at this arrangement right now, there are 10 carbon atoms, and of the 10, 1 and 2 are sp2 hybridized because it is attached by a double bond. So the actual bond angle should be 120 degrees. The rest of the carbon atoms from 3 to 10, they are all single bonded. They are alkanes. They will all be sp3 hybridized. Therefore, the bond angles should be 109.5 degrees. So this will help us in determining the shape or the bond line representation of this compound. Now, in this molecule, you'll find that carbon atoms 1 to 6 written in red or indicated, represented using the red color, is the longest chain. Therefore, the parent hydrocarbon having 6 carbon atoms would be named as hexane. Since there is a double bond between 1 and 2, it will be called 1-hexene or hex-1-ene. If the longest chain is identified, then you will find that there are 3 different points at which you have substituents attached to the carbon chain or the longest carbon chain. On the 4th carbon atom, there are 2 single carbon atoms which will change into the methyl groups, or you can say there are 2 methyl groups. And on the 2nd carbon atom, you have an ethyl group. Here are the alkyl groups. Attached to the 4th carbon atom, you have 2 methyl groups. And to the 2nd carbon atom, you have an ethyl group because there are 2 carbon atoms, 9 and 10, joining together to give you the ethyl group. The alkyl groups become the prefixes to the word root, while we are using the IUPAC system for naming of compounds. Now, arranging the carbon atoms based on their bond angles, which we had seen from the hybridization, we will find that this would be the representation of the bond line formula. The longest chain is numbered, and the substituents are shown by single lines for methyl group and an angular line for ethyl group. And now you can name the compound. On the 4th carbon atom, you have 2 methyl groups, so 4,4-dimethyl. And on the 2nd carbon atom, you have an ethyl group. The prefixes or the substituents are arranged in alphabetical order. E comes before D, therefore 2-ethyl 4,4-dimethyl hex-1-ene would be the name of the compound. And having the bond line formula makes it easy to write chemical reactions as the molecules get more and more complex. That's it for now.